in the last class, we were dealing with so-called what is known as completion of measure spaces. So if you have, so we had examples for spaces which are complete as well as which are not complete, right? So if you have a measure space which is not complete, can we get a smallest completion? So smallest in what sense? That will be done. That is what we have been looking at, right? So first thing what we needed is what is known as a sigma algebra, right? So how did we define? We defined n as all those f subset of omega such that there exists b in A with f contained in B and mu of f is 0. Sorry, mu of B is 0. Yes, so this is what we have. And then we formed A tilde as all those A union F with A in A and F in N. Yeah, in the last class we showed that this collection A tilde is a sigma algebra. Right. Yeah, this much we have seen. Now what we wanted is the next one. We wanted a measure. Yes. So how to define a measure? So we wanted a measure. So define mu tilde from A tilde to 0, infinity as mu tilde of A union F. So what is that we wanted from mu tilde? Yeah, so not only that this is a sigma algebra and A is contained in A tilde. The way we have defined it tells us that A is contained in A tilde. Right. What is the property that we expect from this mu tilde?
That when we restrict mu tilde to A, we get the same mu.
Exactly. So when you restrict this mu tilde to A tilde, A, it should be same as, it should coincide with mu. Because we already know mu. We wanted to extend this mu to a bigger sigma algebra. Yes. Can you guess?
Sir, when A union F is in A, we will define it as mu A union F, and otherwise it will be 0.
If A union F is not in A, you want to define it as 0.
Sir, it will be mu of A.
It will be just mu of A. Yes. So when you define it as mu of A, there is a problem. What is that problem? Well, so first thing you will have to show that it is well defined. So is it well defined? If A union F equal to A dash union F dash. If A union F equal to A dash union F dash, what are we supposed to show in that case?
Mu of A union F equals to mu of A dash union F.
Mu of A.
No, mu tilde of A union F equals to mu tilde of A dash union F dash.
That means
we will have to show that.
That means
mu of A equals to mu of A dash.
Exactly. Correct. So suppose that we have defined this. Well, the first claim is that mu tilde is well defined. So suppose that A union F equal to A dash union F dash. For some A dash in script A and F dash in script N. Yes. Yeah, so then now we'll have to show that mu A equal to mu of A dash, right? Now since F dash belongs to N, there exists B dash in A such that F is contained in B, mu B equal to 0. Well, I'll write it in the next line. F is contained in B, mu B is 0, F dash is contained in B dash, and mu of B dash is 0. Fine. A is contained in A union F, which is same as A dash union F dash, which is contained in A dash union B dash, which implies mu A is less than or equal to mu of A dash union B dash. Now use the subadditivity of mu, which is less than or equal to mu of A dash plus mu of B dash, but mu of B dash is 0, therefore this is equal to mu of A dash. So therefore mu of A is less than or equal to mu of A dash. Yes. Similarly, A dash is contained in A dash union F dash, which is same as A union F, which is contained in A union B, which will imply, so I am just writing it directly, which will imply that mu of A dash is less than or equal to mu of A. I am just putting it as Y. Just fill the same reasoning, whatever we had above. I want you all to write, therefore I am putting this Y. So let me call this as 1, this one as 2. Therefore, by 1 and 2, mu A equal to mu A dash. That is, mu tilde is well defined. Right. Yes, second thing. Now let's do the other things. Yes, now we'll have to show that mu tilde of mt is 0. Yes, how do you show that mu tilde of mt is 0?
Taking f and a both to be empty. So we will get mu of phi.
So note that. So first thing is that note that both. So note that phi belongs to both A as well as N. Therefore, mu tilde of phi is equal to mu tilde of phi union phi, which is mu phi equal to 0. That's it. Second thing, we'll have to show countable additivity. So let E and N in N subset of A be a countable collection of pairwise disjoint sets. Right. So, well, these are from A tilde. Sorry. Right. So now for each N in N, there exists AN in A and BN, sorry, FN. FN in script N such that En can be written as AN union FN. Yes. Therefore, union over N in N, En is equal to union over N in N, AN union FN, which is equal to union over N in N AN, union with union over N in N FN. Thus, mu tilde of the union is equal to mu tilde of this union. Okay, so what will happen to this part? Second union. Where does it belong to? Union over N in N Fn.
Sir, N.
Why?
Sir, we have proved this earlier, I mean.
Exactly. In the last class we showed something that the script N, if you have a countable collection of sets, then union over N in N Fn, what will happen to them? Each Fn you can write it as, so each Fn is going to be contained in Bn, with Bn coming from A, and the measure of Bn is 0. Yeah, all these we showed in the last class, and therefore the measure of the union of Bn is again 0. which tells us that this union is going to lie inside script L. All these we saw in the last class when we showed the so-called fact that A tilde is a sigma algebra, right? Therefore, by definition of mu tilde, this is the same as mu of the union. So, because these ENs are pairwise disjoint, that implies that these ANs are also pairwise disjoint, and therefore, since mu is a measure, this is the same as summation over n in n mu of A. So, since ENs are pairwise disjoint, so R ANs. So this one follows from the fact that since union over n in n, Fn belongs to script. Yes. Right. Now, what is mu of An? What is mu of An?
Mu tilde of An union Fn.
This is from the definition of mu tilde. And what is An union Fn?
En.
That's it. Right. So thus, mu tilde is a measure on and A tilde. So what have we shown? So we have shown that means this triplet omega A tilde mu tilde is a measure space. Right. So we have shown one. Next thing. What is the next thing that we wanted?
It is complete.
Exactly. So next thing that we'll have to show is that this triplet is complete. Yes. How do you show that it is complete? How do you show that it is complete?
We will pick any b from A tilde whose measure is 0
Right.
with respect to mu tilde,
Right.
and we will show that each subset of b is contained in A tilde.
Yes. So let be in A tilde such that mu tilde of B is 0 and let F subset of B. So we will have to show that this F belongs to A tilde. Yes. How do you show that F belongs to A tilde? How do you show that F belongs to A tilde?
Sir, can we use the definition for A tilde? I mean, how we have defined.
Of course.
So, sir, B will be of the form
So
A union F and not A union F, but
so since B belongs to A tilde, there exists A dash in script A and F dash in script N such that B is of the form A dash union F dash. Therefore, 0 equal to mu B equal to, mu tilde of B equal to mu tilde of A dash union F dash equal to mu of A dash. Right. Okay, fine. Then, next. So, F is contained in B implies F is contained in, well, F is contained in, I should write it as A dash union F dash. Now, well, before I write this one, so as F dash belongs to N, there exists B dash in A such that F dash is contained in B dash and mu of B dash is 0. Right. Therefore, F, which is contained in B, but B is A dash union F dash. F dash is contained in B, therefore which is contained in A dash union F dash is contained in A dash union B dash. Therefore, and, so therefore, and. What is mu of A dash union B dash? By subadditivity, this is mu of A dash plus mu of B dash. What is mu of A dash?
it is
Mu tilde of
We have already shown that it is 0. Mu of B dash is also 0, so 0 plus 0, which is 0. So these two together imply that F belong to N. So which implies that F belongs to A tilde. That's it. Right? And we are done. Right. So next one. What is that? So why should one construct such a completion? What is the point behind coming up with such a completion? Because we know that the power set itself is a complete sigma algebra. We know that there exists a sigma is the smallest. In fact, there exists a complete sigma algebra. In fact, complete measure space. You look at the power set sigma algebra. But that is not our goal. Right. Yes, so the measure space omega A tilde mu tilde is the smallest complete measure space in the sense, well, smallest measure space containing, this is very important, omega A mu. Mu in the sense that if omega dash A dash mu dash is any other, is a complete measure space, with A contained in A dash and mu dash of E is equal to mu of E for all E in A, then A tilde, whatever we have constructed, is going to be contained in this A dash. Yes. Yes, how do you show this? Yeah, so let omega dash A dash mu dash be any complete measure space such that,
Sir, in the theorem, I think A dash आएगा.
Thank where where is
Instead of
that?
A subset of A dash.
Right here. Thank you. Thank you. A is contained in A dash and this mu dash restricted to A is equal to mu. Yes, so you will have to, so yes, so you have this. Fine. How do you show that this is the smallest? How do you claim that A tilde is contained in A dash? How do you show this? What are we supposed to show?
Sir, we will choose a general element from A tilde and we will show that it is contained in A dash. Any element of A tilde is of the form A union F, or A belonging to A and F belonging to N.
Right. So let E belong to A tilde. Then, by definition of A tilde, there exists A in A and F in script n such that E can be written as A union F. Yes, others.
So why we're taking omega dash here? I mean, omega should be same now.
Which one?
Like we have the set on which we're defining sigma algebras omega, and then we're taking omega dash.
Thank you, thank you, thank you, thank you. This is not omega dash. Thank you. Yes. Such that E is of the form A union F, and then
Sir, now there exists a B belonging to A such that F is contained in B and mu of B is 0. And then what we will do is we will show.
that's right. So as F belongs to N, there exists B in A such that mu B is 0 and F is contained in B. Right.
Since B belongs to A, B belongs to A dash.
And therefore?
And therefore F belongs to A dash.
Why?
Because A dash is complete.
Exactly. Right. So since B belongs to A, it follows that B belongs to A dash. And also as omega A dash mu dash is complete, it follows that F belongs to A dash. That is by the definition. Right. A dash, and also as sorry, I need one more. Not just that it is complete, as complete and also and mu dash of B, which is same as mu of B, because B belongs to A, mu dash is same as mu, which is 0. We have F belongs to A dash. Therefore, E equal to, we have written it as A union F. A is from the original sigma algebra A, which is also in A dash. So A belongs to A dash and F is also in A dash. So therefore this belongs to A dash. And that's what we wanted. Is that clear for all? Everyone? Yes. Yeah, I still have 10 minutes time, but right. Yeah. I'm sorry. Why am I asking this? Sorry will be clear in a moment. because I'm going to give you some exercises again. Yeah, so let me begin with the definition, because I've written it as Cartheodary extension theorem, although I'm not going to do the theorem today. So let me begin with the definition. Well, how did we start with? We started with what is known as a concept of outer measure. In fact, Lebesgue outer measure. We had something like what is known as a length, and then based on this length, we defined what is known as a concept of outer measure, right? So this procedure of outer measure not only works on R, it is actually a more general concept. That's what we are going to see. Yeah, so let omega be any set. Yes. A function mu star from the power set 2 raised to the power omega to 0 comma infinity is called an outer measure if it satisfies the following three conditions. First one, mu star of mt is 0. Second, monotonicity A contained in B implies mu star A is less than or equal to mu star B. Third one, countable subadditivity. Mu star of the union is less than or equal to sum of the individual. Yeah, so this is monotonicity. This is countable subadditivity. Right. Yeah, so this lemma, we have almost done this lemma, but only thing is that we did not do it for a general, but what we did is only for the Lebesgue measure. Well, let A naught be an algebra on a set omega, and let mu naught from A naught to 0 comma infinity be such that mu naught of mt is 0. Define mu star from 2 raised to the power omega to 0 comma infinity by mu star of any set is infimum over sum of the individual mu naught of, yes, so that is where we started with mu naught of an, so that A is contained in union over n and n an with an coming from this a naught for all n in n. Right. Then, so once you have defined all these, then this mu star is an outer measure. So proof it's very easy for me. Why? Why is it easy for me? Why is it easy for me? Because I'm going to leave it as exercise. Exactly. Yes. Either prove it now, it will be easy for you, or when the turn comes, you will have to prove it in the tutorial classes. Either now or in the tutorial class. So you decide when to prove and when not to prove. Yes. So yeah. Here I have enough of exercises. Of course, even I have something to do. That right, I'm not denying it, but right? Yeah. So I don't want to proceed further. If you have any questions, then yeah. So I have few more definitions, and then well, so how you have the so-called Lebesgue measurable sets? We have what is known as the so-called mu star measurable sets. Same definition. All these are proposed by Cartheodary. The one that is for Lebesgue measure was proposed by Lebesgue, and what is proposed generally is for Cartheodary. This procedure works. This is what Cartheodary observed in 1920s. Lebesgue he proposed in the beginning of the last century, and in 1920s and 30s, Cartheodary he produced. He showed that no, this procedure works for a more general thing, which we are seeing now. I don't want to repeat the proof because same steps with some minimum set of changes. So I don't want to. And this is what I have been telling you. Please be careful. Look at all the steps, whatever I am doing, because you are going to do it again in a different context, and the context have come today. Fine? Right. If you have got any questions. Yes, Vash. Yes.
Why we are not taking sigma algebra A naught?
Sorry.
We are taking A naught to be an algebra.
Yes.
In the dilemma. Why not sigma algebra?
You don't need a sigma algebra. That is the whole point. You don't need a see. Is length defined on a sigma algebra? No. Is the concept of length defined on a sigma algebra? No. It is defined on some intervals, and on some, and at most you can extend it to some finite union of disjoint union, finite disjoint union of intervals. Only this much can be done, and that's exactly I've done. And if you notice that if you look at the finite disjoint union of intervals, that is not going to give you an algebra but something else. But one can improve it. You can make it into an algebra. Well, look at this algebra generated by intervals, all intervals. Then you should be able to. Still, there you can define the notion of length at most. You can see, you can extend it, but it is not going to be exactly length. Length doesn't make sense. In that case, you will get what is known as an outer measure. Fine? So here this mu naught is playing the role of length invariably. Any other questions?